Hello and welcome to assignment 2 of Strategic Games for Business. Today we'll be looking at strategic interactions and conducting analysis on true events. You'll hear from Joshua Jansen, Jacob Whitehouse, and Elia Perona. Thank you for listening. Jacob and Josh stumble upon a gold coin on a table while studying for an upcoming quiz. Not belonging to either player, a fair simultaneous game was chosen by both players, agreeing to play rock, paper, scissors over the course of 10 games. The rules of the game are simple and both players are comfortable with how to gain points. This simultaneous game is referred to as a zero-sum game. An interaction within a zero-sum game follows the parameters that for each point obtained by a player also has a corresponding loss to their opponent. The only occasion where players would share the same payoff in a zero-sum game would be a draw, which is possible if both players choose the same move within rock, paper, scissors. This particular game could be considered a game of perfect knowledge. Given the scenario, both players follow a pure game, applying an even distribution to how often each of their moves is selected, also considering as played as random. However, it is entirely possible for players to develop and execute a mixed strategy. To give an edge within the game by emphasizing unpredictability, Josh has deviated from playing a game of perfect knowledge and imposed a mixed strategy within his moveset. The strategy chosen saw a greater emphasis on the use of rock, seeking a strategy his opponent is unlikely to notice and adjust his strategy accordingly. In a perfect game where each player delegates equal probability to each of their moves, an equilibrium would not exist, as it is unclear to the players what would be gained by deviating from one's moveset or imposing a mixed strategy upon a zero-sum game. If a player were to understand the exact move his opponent were to make, having either told his corresponding player his next move or have their strategy exposed, then a best response may be apparent and therefore an equilibrium may be fixated upon. After analysing the patterns played by Josh, he has shown a great liking to the move rock. After conducting calculations to uncover the greatest expected payoff for Jacob, paper was found to provide the best results, having expected payoff of 0.4. This is the highest observed within the calculation, as rock provides an expected payoff of 0 and scissors of negative 0.4. Jacob's most efficient move to maximize points is to strictly play paper. This provides a dominant strategy for player 1. Thank you for listening. I'll now hand you over to Jacob.
Thanks, Josh. I'll be introducing parts C and D. Part C asks us to describe strategic moves that you could have used to improve your payoff in this game. Strategic moves highlights how to obtain an advantage over one's opponent to ultimately maximize their own payoff. In this game of rock, paper, scissors, some of the strategic moves comes as follows. Pattern recognition can be used as a strategic move to ultimately identify any repetitive responses. This means becoming observant of your opponent's responses to try and pick out any biases that they may have to ultimately come up with a winning response. Secondly, in this game played, Jacob could have used psychological tactics as a strategic move, as it would have been beneficial to manipulate Josh. Through forms of intimidation or even some forms of bluff, Jacob could use this to trick Josh into playing the game how Jacob wants to play, and ultimately force winning responses through Josh's errors. Lastly, Jacob could keep mental notes of the observed moveset deployed by Josh. This means to keep track of what Josh has played and what he may choose next. Now on to part D, which asks us, how did you play the game and what was the outcome of the game? And given your analysis, how would you have played the game differently? Josh won the game, and as Jacob was unable to find a winning response. Jacob could have played the game differently by deploying paper 100% of the time, as it would have beaten majority of Josh's responses, which were rock. This would have likely worked, as we know that Josh is a committed player and is unlikely to change his strategy from game to game. As a result, this leaving Jacob with the best chance to come up with more winning responses if the game was played differently for a second time. Now passing on to Ilya.
All right, thank you, Jacob, for that. So the particular game that we have decided to undertake in this is a negotiation-based game for strategic interaction that occurred in my life where I experienced that of purchasing a vehicle. A sequential game is that where the game consists of multiple players who are not making decisions simultaneously at the same time, with each player's decision being influenced by past moves. It's also safe to assume that previous set or active information is also known to the current players making that decision, taken from Chang 2015. The rollback equilibrium for both player 1 and player 2 is 26,000, negative 26,000, which is counter offer, except starting from the left. The reason we get this from starting from the right side now, from backwards, the rollback equilibrium, the fourth node player 2, which is myself, would be the smartest option to counter offer, as I either lose 0 or lose 28,000. When you move to the third node player 1, their best response would be to accept 26,000. The reason for that is if he was to counter offer, he knows that I would choose 0, so he basically gains nothing. Moving to node 2, I can either accept or counter offer. If I accept, I lose 30,000, or if I counter offer, I know that player 1 will accept the 26,000, so I lose 26,000. So my best response will be to counter offer. And then moving to the very first node, player 1 can either accept 24,000 or counter offer, knowing that I would then counter offer, and then he has the option to then accept for 26,000, which is greater than 24,000. So that's how we get the counter offer, accept, where the rollback equilibrium for player 1 and player 2 is both 26,000 and negative 26,000. Advantages to being the first mover come from the ability to commit oneself to an advantageous position and to force the other player to adapt to it. And the second mover advantage comes from the flexibility to adapt to oneself and others' choices. Take from lecture notes, week 2, page 28. So with the first mover advantage, a sequential type game would be that we have the ability to sort some initial advantage by setting the price of the negotiation. The first mover advantage may occur in a sequential game with a second mover, who in this case is the seller, may counter with the lower price of sale to what is initially thought as of the first mover advantage, has been strategically influenced the second mover. Along with the first mover advantage in game theory, that could be reflected in the scenario as being the first mover, which affects that of the competitors, as you were the first to put a price on something, which is affecting that of the next move of the competitor they may make. So they might, well, they're going to offer lower. As we know, the first mover advantage influences the second mover in an advantageous way. However, the second mover advantage is a situation where being the second chooser is better option than choosing simultaneously, whereby the second mover's advantage becomes present when going second allows for the use of previous choices made by the first mover, taken from sailor.org. Also note that the second mover gains information to previous made decisions, where the information can be strategically used to manipulate the next course of the game where the player's decision may be affected. Finally, summarizing the sequential game that we have just played, which was a real-life negotiation event that occurred when I was trying to buy the car. The game was played with two people, one being the seller of the vehicle and one being the purchaser of the vehicle, which was myself, player 2. In the game, P1 got made an offer by P2, myself, which is what started the negotiation as shown on the previous slide. The tree. The outcome of the game in the real life was that sale was for 28,000 of the vehicle, although the backwards equilibrium of the game reflected an outcome of 26,000 for the seller and a purchase price of 26,000 for the buyer. And how could the game be played differently? Strategies that come to mind would be to firstly reduce the counter offer price. Instead of using increments of 2,000, 1,000 would be more beneficial or effective, and even using increments of 500 as the game gets a bit closer to try to, I guess, either pay less or receive more. Additionally, playing the game for more rounds may add to a higher payoff for either party, as the seller may make more depending on how adamant the buyer is, and vice versa, where the buyer may make more depending on how adamant the seller is to get rid of the vehicle. And that's it for our presentation. Thank you for, I guess, attending and listening.